Hello students, I'm going to do a video for you since I'm not going to be in class on Monday, 7th period. I'll be at a track meet, and so we're going to get some instruction done this way and you can watch it and go from there. Feels a little bit like I'm a year ago at COVID because I did these all the time then, so we're going to see how it goes. The rest of my family is asleep, so I'm talking quietly. Hopefully you can hear me okay. What I want to talk is kind of to continue on what we did on Friday. If you recall from Friday, we worked on, I guess I should have started with this instead. We worked on taking quadratic equations, and this one happens to be in standard form, and we worked on converting them to factored form. Okay, so we're going to continue to do that today, but I want to do it in the context of actually using this to find roots, zeros, solutions, x-intercepts. They all mean the same thing. Okay, we're going to use factored form to do that. We're also going to use the famous quadratic formula. This should look familiar. Remember what we're doing here. Both this as well as the factored form that I'm going to show you helps us find the x-intercepts of a quadratic function. Okay, this will give you those. Also putting it in factored form, and I'll show you that here in just a minute. All right, so here we go. So we're first going to factor this, put this in factored form. So I showed you this briefly on Friday, but we kind of got cut short. Remember, we're trying to find two binomials that multiply together to get us that. So we're kind of undoing our foiling. We call it factoring. So here's really the thought process I go through. I make a little t-chart where I put the leading coefficient here and the constant here. Okay, and I think of that, I got to keep in mind that that's negative. So they're going to have to, one's going to have to be negative, one's going to have to be a positive to multiply to get negative 24. Okay, and so I list factors. In this case, factors of 5 are 1 and 5, factors of negative 24. And I'm not going to worry about putting one of these negative yet, but you could have 1 and 24, 2 and 12, 3 and 8, or 4 and 6. Those are all factors of 24. Okay, now what this allows me to do is kind of think ahead and say, okay, which combination of, well, obviously I only have one factor here, so I have to use the 1 and 5. But over here I could either use the 1 and 24, 2 and 12, 3 and 8, or 4 and 6 to go here and here. So I'm thinking about numbers that are going to have a difference of 37 when I subtract them. So after I multiply factors here with factors over here, they have to have a difference of 37. So let me explain. If I went 5 times 24, that would be 120, and 1 times 1 is 1. Well, those are my products. Do they have a difference of 37? No, they don't. Okay. I could also check diagonally. Okay. 5 times 1 is 5. 1 times 24 is 24. Do those have a difference of negative 37? No, they have a difference of 19. So then I just keep trying. 5 times 12 is going to be 60. 1 times 2 is 2. Nope, they do not have a difference of 37. 10 and 12. Nope. So I go to 3 and 8. 5 times 8 is 40. 1 times 3 is 3. Hey, that does have a difference of 37. So I know I'm going to use these two factors, and I know I'm going to multiply 5 and 8. That gives me 40, and 1 and 3 gives me 3. It's a difference of 37. So I come up here and say, okay, I'm going to put the 5x and the 1x in these spots. But then the question is, where's the 8 have to go so it gets multiplied by the 5? Well, it's got to go there, because I don't take this number times this one in my foiling process. I take 5 times this one. So that's got to be the 8. The 3's got to go there. This one would have a product of 40x. This is product of 3x. In order to add to a negative 37, this has got to be negative. So I know my negative's got to go there and my positive there. Okay. Now, you could do more just guessing and checking, and that still gets you to the end result. I think my way just is a little more efficient and helps me do a lot of that thinking in my head without having to write it out. So anyways, we've accomplished our goal of putting this in factored form. That's kind of where we left off on Friday. But let's say now that the goal was to find the roots, zeros, or factors. Okay, and so essentially what that's doing is saying, okay, when the y value is 0, what is the x values? Okay, and in this case, when you have the one side equal to 0, and you have a product of two numbers, or in this case two binomials that multiply to 0, you solve that by using the zero product property, which means you set this factor equal to 0 and you set this factor equal to 0. Okay. Now you can simply solve those. Subtract 3. 5x equals -3 divided by 5. X is -3/5. That's one of my roots, one of my solutions. The other one is x equals 8. Okay, so I know that's where this parabola crosses the x-axis, and I have solved it. Okay, now that is one method of doing it. The other method, and I don't know if I'll have enough room, but I'll try here. The other method is to use the quadratic formula. Okay, so a lot of times we use this when it won't factor like this, or if we don't want to go through this work, we can just use that. So here we go. X equals -b. The b value is here, so the opposite of -37, so it actually ends up being +37, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Looks kind of messy, but let's grab our calculators and see what we get. So I'm going to multiply what's called the discriminant, simplify everything under the square root first. Alright, so I got -37 squared minus 4 times 5, 24. So that part right there simplifies to be 1,849 all over 10. And then when I take the square root of that, I get a nice 43, so I get 37 plus or minus 43 over 10. You have to make sure you do the numerator first. So I'm going to do 37 plus 43. That's going to give us 80. 80 over 10 is 8. There's our first solution, same as what we got up there. And then when I do -37 minus 43, I get a -6 over 10, which reduces to -3/5. Okay. So these are two ways of solving quadratics. That's what you're going to be working on today in your lesson. So hope it goes well, and we'll see you after A term.